Well, hello and welcome to skill lesson 14, rotating a figure. By and large, one of the more complicated transformations there are, but keep in mind a rotation is a transformation that does not change size or shape. It is a rigid motion. So when we graph these images, we should see the same size and shape of our pre-image. There's a couple key words in here. We're going to use the terms clockwise and counterclockwise pretty heavily. We're going to be talking about a certain number of degrees. I will say that unlike the reflection, these functions that you see here, probably wise to study those. I'm going to show you hopefully, a nice way to memorize one of those functions, and then you can memorize all the others pretty easily. Because the function is pretty intense, or because the rotation is pretty intense, memorizing those functions might not be a bad idea. So feel free to take a look at the examples, but we're going to go and start with the practice A, number 1. So our first direction tells us to take these pre-image points and rotate them 180 degrees about the origin. So the functions on the previous page, if you actually looked at those functions are designed for rotating around the origin. When you see on this next set, after 1 through 4, you'll see what happens when we don't rotate around the origin, how it alters slightly. So one of the easiest ways to memorize the functions is think about what these rotations are actually doing. So if you notice, most of the functions start off with xy goes to such and such. Now, what we're really saying is some point is going to change location. So let's say we have some point up here at 12 o'clock or on the y-axis. Well, if we were to rotate 90 degrees clockwise, we're going this direction, right? We're going down. So what happens when you rotate 90 degrees is we're going to swap our x and y. We did a little of that on reflection. We're going to swap x or y. And then if you think about it, if we start up here in the first quadrant and then move down to the fourth quadrant, everything, or the x values in the fourth quadrant are positive. Everything to the right is positive. But then moving down, our y values are negative. So after we swap our y and x, we're going to change the sign of our x. So a 90-degree clockwise rotation is the function y negative x. Now that is truthfully the only function you have to memorize, because if you really consider the other rotations that we have, they're just the exact opposite. For example, if 90 degrees clockwise is the exact opposite of 90 degrees counterclockwise. So if the function for 90 clockwise is y negative x, we're going to do the exact opposite, or do the exact opposite signs of y negative x, and it'll be negative y positive x. So, and the reason being, because we're going left and then up in the 90-degree counterclockwise rotation. So negative then positive. Now the 180-degree rotation, we don't actually have to specify clockwise or counter. If you notice, all it said here was 180 degrees, is because it's just literally the exact opposite direction. Just the same way we approach 90 clockwise and 90 counter, we're going to approach any given coordinate. We're going to use the exact opposite signs for a 180-degree rotation. So 180-degree rotation is the exact opposite signs of our original coordinates. So it'd be negative x, negative y. So if we understand what we're really saying here with x and y, and our first function, 90 degrees clockwise, we should be able to fill in the pieces for 180 and 90-degree counterclockwise. So let's take a look. Number 1, it tells us to rotate 180 degrees about the origin. So in reference to the functions, all we're going to do is change the signs of each of these x and y values. So j prime will be located at 3, negative 4. K prime will be located at negative 1, negative 4. L prime will still be located at 0, 0. And not just because it is 0, but because we are rotating around the origin. If you remember that the center of the rotation, which in this case is the origin, does not move. Just like on our previous transformation, the reflection points on the line of reflection do not move. Last but not least, M prime, we're going to change the signs to 1, 1. So we'll go ahead and graph this one just so we can see what a reflection or rotation 180 degrees about the origin looks like. So I'll hop over to my graphing. So -3, +4 will be at +3, -4, 1, 2, 3, 4. So J prime will be located here. K prime was located at 1, 4, so it will be at -1, -4. L prime is going to stay in its same location as its original pre-image point, and M, which was located at -1, -1, will be located at 1, 1. So if I can connect this a little bit, you'll see how this, you might think it's a reflection, but it's definitely a rotation, because we see that J ended up all the way over here, K ended up all the way over here, L, of course, stayed in the same location, and M ended up all the way over here. If you notice, what I just drew with these pink arcs is essentially half of a circle, which is 180 degrees. So you can kind of view it that way as well, because each point is rotating 180 degrees around the origin. So that's where our image should end up. Now let's go and clear that, and we'll move on to our next rotation. So number 2 asks us to rotate 270 degrees clockwise about the origin. Now, if you noticed a moment ago when I was trying to give you a way to memorize the functions, I didn't even mention 270 degrees. That is because 270 degrees clockwise actually shares the same function as one of our 90-degree rotations. So let's talk about that for a second. So if we start up here and go 270 degrees, this is 90, 180, 270. 270 degrees clockwise is the same as 90 degrees counterclockwise. So the function we use for 90 degrees counterclockwise is the same function we'll use for 270 degrees clockwise, which is actually nice for us to understand, because then we don't have double the amount of functions to memorize. We can just memorize the 90 degrees counterclockwise. But please understand, 270 degrees clockwise and 90 degrees counter are the same rotation, or at least the same image result, not necessarily in the same direction. So 90 degrees counterclockwise, we are going to swap these two for starters. And then change this first sign. So I always swap the X and Y first, then change signs, especially when, and it didn't happen in this case, but that -3 could have potentially been changed to a +3. So K prime, we're going to swap 1, 4 to 4, 1, then change the +4 to a -4. Now, again, L is not moving because L, 0, 0, is located at the center of this rotation, which just so happens to be the origin. M prime, now you're not going to really see anything switch at first because these are the same X and Y value, but trust that we are doing that, -1, -1, and then change this first sign to a positive. So you can just erase the positive there. I like to go ahead and just put a +1 just so I know that I changed the sign. So let's go ahead and graph these 4 points. So J prime will be located at -4, -3. K prime will be at -4, 1. L prime will remain at the origin, 0, 0, and M prime will be located at 1, -1. So notice there's two ways we can view this. We could say that J went all the way around here, 270 degrees clockwise, or simply view it as 90 degrees counterclockwise. And if you notice, it's a pretty terrible circle, but I did make a circle here, total 360 degrees, because 270 clock and 90 counter is 360 degrees. So there's two ways to view that rotation. And it's definitely helpful if we memorize that it is the same as 90 degrees counterclockwise, because we don't have to memorize just another set of functions here. Now let's look at item 3. We're going to rotate 90 degrees clockwise about the origin. So first thing we're going to do is swap x and y. And then we're going to do the exact opposite here. If you recall, what we did was once we swapped x and y, we changed the first sign, right? 4 went to the front and we changed that first sign to -4. Well, after we swap these two, we're going to change the second sign. So it'll be +4, +3. So K prime, we're going to swap 1 and 4 to 4 and 1, and then change the second sign to -1. L prime, again, will be in the same location because it's the center of the rotation. And M prime, trust me, I am swapping the two -1s, although it doesn't seem like I am, and then changing the second sign. So it'll be at -1, +1. Now let's look at item 4. Of course, I invite you to graph number 3, but we're going to go and move on to item 4. So it says a rotation of 90 degrees counterclockwise. Well, just a moment ago, we said that a 90 degrees counterclockwise rotation is the same thing as a 270 degree clockwise rotation. So the image points of number 4 should actually be the same as number 2. And unless you watch this video, you might have just gone through the whole rigmarole again and didn't realize it's actually the same rotation. It's a different direction and different number of degrees, but it ends up in the same location. That's really all we're concerned about in a transformation. So the vertices for number 4 should actually be the same for number 2. So that's the end of practice A. Let's go and move on to practice B. You'll notice on example B, what changes now is our center of rotation is not the origin, but a different point. So we're going to look at how to approach it when the center of rotation is not the origin. Because I told you that the functions as they were written were originally designed for a center of rotation at the origin. So how do we approach this on number 5? So let's talk about it. So number 5 says we're going to rotate the same pre-image we've been dealing with the whole time, 180 degrees about the point 20. About the point 20. So there's a little process that we're going to do here, and I'll just kind of list it to the side. What we're going to do is we're going to take each pre-image point and we're going to subtract the center of rotation. We're going to subtract the center of rotation from each pre-image point.
1 minute.
Sorry about that. Recording at school, of course. After we subtract the center of rotation, and what we're really going to do, and I'll explain when we graph it, is we're really shifting everything to make the center of rotation the origin. Then we're going to perform our rotation, whatever it is. So we're going to use the function of our rotation, because the idea here is the functions were written as if the center of the rotation was the origin. So by subtracting the center of rotation, we shift everything to where it would be if the center of rotation was the origin. Then we use the functions. Then, after we use the function, we're going to add the center of rotation back, because, of course, the center of rotation was not the origin, so we have to shift everything back. So really what we're doing is performing a translation using a rotation and then translating it back to where it should be. So let's take a look at that on the graph. So now our center of rotation is not the point 0, 0, but the point, I believe it was 2, 0, just to make sure. So the point 2, 0 will be right here. So even just shifting to the right 2 units, moving our center of rotation to the right 2 units will ultimately change what happens to each of these points under these new rotations. So we're going to take J, which is located at -3, +4, and the first thing we're going to do is we're going to subtract our center of rotation. So we're going to take -3 and subtract the point 2, 0. So we can only subtract like values, so -3 and +2 are like terms. We're going to do -3 minus 2, and we're going to subtract 4 and our y value for J and our y value for the center of rotation, so 4 minus 0. So -3 will take away 2 and get -5. 4 will take away 0 and get 4. Now what we're going to do after that step, and so just to kind of show you what happened here, it's J we just shifted to right here. Notice we went 2 units over. That's because the center of rotation located at 2 units, if we want to move it to the origin, we need to move it 2 units to the left. So that's what we're really doing with every single coordinate. We're going to shift every single coordinate to the left 2 units, then apply the rotation. So now what we're going to do is use the function, which for 180 degrees, we're going to simply change the sign of our x and y values. So it'd be at +5, -4. So now +5, -4, which would be way over here. Notice what I just did is I took this point and I rotated 180 degrees around the origin. And now, because it wasn't originally shifted left 2, we need to add that center of rotation back. So we're going to add the COR, essentially move it 2 units back to the right. So we'll take 5 and add 2, -4 and add 0. And so it is a long process here, and some of you might find some shortcut ways to approach this, but this is definitely a method that does work. So J prime will be located at 7, -4. Again, notice what I did is that now I just shifted it back 2 units to the right. So J prime will be located at 7, -4. Go and clean this up a little bit. Now we'll approach K the same way, although I'm probably going to run out of room. As you notice, it's quite a lengthy equation if you want to look at it that way. So K is located at 1, 4. So we're going to subtract the center. So it would be 1 take away 2, and 4 take away 0. 1 take away 2 is -1. 4 take away 0 is 4. Now we're going to use the function, which tells us to change the sign of both. It's a 180-degree rotation, so it'll be a +1, -4. And then we're going to add the center of rotation back, which will be, I'm just going to put it below. Hopefully that doesn't hurt you too much. It'll be 1 + 2 and -4 + 0. So we're adding the point 2, 0 back. And we'll end up at 3 for, let me write K prime. 3, -4, which will be 1, 2, 3. Now we'll do the same thing for L and M, because L is not the center of rotation anymore as the origin, so we definitely have to rotate L as well. So L is located at 0, 0. So the first thing we're going to do is subtract our center. So it'll be 0 take away 2 and 0 plus 0. 0 take away 2 is none other than -2. 0 plus 0 is none other than 0. Now we're going to perform the transformation, or the function, use the function by changing each sign to +2, +0. And then we're going to add our center of rotation back. So it's currently at the point 2, 0. So then we're going to add the point 2, 0 back. So L prime will now be located at 4, 0. So if we graph L prime, this one would definitely be easier to see, that it was in fact a 180-degree rotation around the point 2, 0. That's a little bit easier because it's a lot closer to this center of rotation. Last and certainly not least, poor old M, always getting the last one here. So we're going to take the coordinate -1, -1. We're going to subtract 2 from our x, add 0 to our y. -1 take away 2 is -3. -1 take away or add 0 is still -1. Now we're going to change the sign because that's what our function tells us to do. Change the sign of both the x and y value. So it'll be a +3, +1. Then I need to add the center of rotation back. So I'm going to add 2 to our x and add nothing to our y, so that M prime is located at 5, 1. So M prime will now be located at 5, 1, which will be here. And hopefully we can see that it is a 180-degree rotation around the point 2, 0. So a little bit more math involved, but nothing we can't handle. Really, if we look at it, it's just adding and subtracting 2 and 0 in like terms. So number 6, we're going to rotate 270 degrees clockwise about the point 2, 0. Notice I kept the same center of rotation, 2, 0 for all of these. Feel free to change it up if you prefer, just for the sake of extra practice. But we're going to rotate 270 degrees clockwise about the point 2, 0. So we're going to go through the same process here. So J, that's located at -3, 4. We're going to subtract the center of rotation. So it's going to be -3 take away 2, and 4 take away 0. -3 take away 2 will be -5, and 4 take away 0 will be 4. Now, this is where it changes slightly because we're doing a 270 degrees clockwise rotation. 270 degrees clockwise rotation will swap y and x and change the first sign. So that's what I do first. Notice how I said it. We swap y and x, so it'd be 4, -5, and then change the first sign. So now it's going to be located at -4, -5. Then we add the center of rotation back. So J prime, I'll show that work actually. So we'll add 2 to our x and add 0 to our y. So J prime will be located at -2, -5. So J prime is located at -2, -5. So there's our center of rotation to 0. So hopefully you can see that we did rotate 90 degrees counterclockwise or 270 degrees clockwise. So let's go and continue the process with K being located at 1, 4. So we're going to subtract our center, 1 take away 2, and 4 take away 0. 1 take away 2 is -1, 4 take away 0 is 4. We're going to use the function that tells us to swap our x and y, and then change the first sign. Now we need to add our center of rotation back, which will be adding +2 and adding 0. So K prime will be located at -4 + 2, which is -2, and -1 + 0, which is -1. So K prime will be located at -2, -1. Moving right along. Hopefully we're getting a really good sense of how to approach this. So L, still located at 0, 0. Again, we have to rotate L because it is no longer the center of rotation. So we're going to subtract 2 from our x and subtract 2 from our y. We'll end up with -2, 0. Then we'll use the function here, which tells us to swap x and y and change the first sign, which changing 0 will remain 0 because it's neither positive nor negative. Then we add our center of rotation back. So we'll add 2 to 0 and add 0 to negative 2. 0 plus 2 is 2, and negative 2 plus 0 is negative 2. So we are going to be looking at 2, negative 2. So again, L is probably the easiest one to see. If you notice, we rotated. You could either view that as 90 degrees counterclockwise or 270 degrees clockwise. So that's a great one to check to make sure you're performing this rotation correctly. Last and certainly not least, M is located at -1, -1. So we're going to add 2 to our x. No, excuse me, subtract 2 from our x. Goodness. Even when you do it so much, you start to forget and subtract 0 from a y. -1 take away -2 is -3. And -1 take away 0 is -1. Then we're going to use the function here, which tells us to swap x and y. So I'm just going to bring that down right below it. And then change the first sign. Notice I'm going to go and just write a +1. You can just get rid of the negative altogether. Just understand that it is a positive 1. Now we're going to add our center of rotation back. So 1 plus 2 and -3 plus 0. So M prime will be located at 1 plus 2, which is 3, and -3 plus 0, which is -3. So 3, -3, which will be here. Now, I always invite you, and this is one of the benefits of graphing, is a rotation is considered a rigid motion. So the size and shape of our figure should not change. So if K is 1, 2, 3, 4 units from J, then K prime has to be 4 units from J prime as well. So that's a great way to check that you're actually performing these rigid motions correctly if your size and shape did not change. So that is a 270-degree clockwise rotation, or again, we could view it as a 90-degree counterclockwise. So the last one I'm actually going to perform along with you, number 7, because 8 is actually just like number 7, because we're describing 270 clockwise, the same as 90-degree counterclockwise. I'm going to go and do number 7 with you, a 90-degree clockwise about the point 20. So still the same center, but a 90-degree clockwise. So let's persevere through this. We have one more to do. So J is located at -3, 4. So we're going to subtract our center. I'll go and graph that again if you want me to, if it would help. So we're going to subtract our center. So we're going to subtract 2 from our x and subtract 0 from our y. -5, +4. Now 90 degrees clockwise rotation, we're going to swap x and y and change the second sign. So the -5 will now become +5. Then we need to add our center of rotation back. So we'll add 2 to our x and 0 to our y. So J prime is located at 6, 5. So J prime will actually be over here. Now K prime. So let's tackle K. K is located at 1, 4. Subtract 2 from our x and 0 from our y. 1 take away 2 is -1. 4 take away 0 is 4. We'll swap our x and y, then change the second sign. So notice I swap first because that -1 is going to change to a +1. Then we need to add our center of rotation back. So we're going to add 2 to our x and 0 to our y. And K prime will be located at 6, 1. So K prime is located at 1, 2, 3, 4, 5, 6, 6, 1. And notice J prime and K prime are still 4 units apart. Let's look at L. So we're going to subtract our center. So we're going to subtract 2 from our x and 0 from our y. Seems silly to do that, but we have to here, just so we get in the habit of approaching this math correctly. 0 take away 2 is -2. 0 take away 0 is 0. Then we are going to use the function by swapping x and y, and then changing the sign of our second value. So it'd be 0, +2. Now let's add our center of rotation back. So we're going to add +2 to our x and 0 to our y, so that L prime is now located at 2, 2. Again, this one's the easiest one to see, a 90-degree clockwise rotation around this center of rotation, 2, 0. Last and certainly not least, M, which is located at -1, -1. We're going to subtract 2 from our x and subtract 0 from our y, so that we're at -3, -1. Then use the function, so we're going to swap x and y, and then change the second sign, so it'll be at -1, +3. Again, we're using the function, which tells us to swap x and y and change the second sign. Now let's add our center of rotation back. So we're going to add 2 to our x, add 0 to our y, and M prime will be located at 1, +3. 1, +3, which would be here. Just quickly connect it, just so that we see we really did perform a 90-degree a 90-degree clockwise rotation. And don't forget, just like the 270 degrees clockwise and the 90-degree counterclockwise are the same, 90 degrees clockwise can also be described as 270 degrees counterclockwise. So keep that in mind. Now, because I've already stated that the coordinates for item 8 are going to be the same as 6, simply because the resulting image will be the same vertices, I'm not going to go through that process there. So this is the end of skill lesson 14, rotating figure. Hope that helped. Thank you for watching.